Hello, my name is Brandon Clayton, the Algebra Guy, and today we're going to be discussing simplifying expressions by combining like terms. So by the end of this video, you'll be able to do problems like this. Simplify this by combining like terms. Can you do this now? If you know a little bit and want some practice, you'll stay tuned. If you don't know at all, stay tuned again, and we're going to talk about how to do that. All right, the questions that we're going to answer are as follows. How do I simplify expressions with like terms? Pretty simple. I want to start out with this simple model. So we have oranges plus oranges equals what? So we got 4 oranges plus 3 oranges. That obviously equals oh, I'm about to mess it up. Something that simple. 7 oranges. And I'm able to combine these two because it's like terms. They're the same things that we're talking about. You can't combine unlike things, which we'll talk about in a second, but these are alike, so we can combine those. You could have rewritten that to just simply say 4 oranges plus 3 oranges, and it look like this. Now, mathematically, why am I setting it up this way? Because you're going to see 4x plus 3x equals 7x, just like we would say is 7 oranges. So some number of oranges represented by x. So that's the big idea. Let's click through and see if we can get to what it's not like. But first, how do I simplify expressions with like terms? So these 3 steps will help you. First, identify like terms. We're going to identify like terms. Number 2 is kind of optional. You could rearrange the problem so that you can get the expression with like terms all together, so it's easier to see. Not necessary, but it helps if you're first starting out and want to make sure you're doing it right. And lastly, we add the coefficients of the like term. So here's an example problem right here. So let's go through those steps with this example problem. Identify the like terms. So what are like terms? So in our last lesson, we talked about how to identify terms that are alike. And we look at a variable that have the same exponent. So I have an x here. And that's all I have. I meant to put another x, but I forgot to. But that's, you know what, I'm going to go ahead and add another x because I want to make sure we get this. So we got 5x. So I got 2 like terms. So I got a 5x and I have a 3x. Notice the rest of these are y. So they have the same exponent, x to the 1, which we don't write usually. But I can add, so identify the like terms by circling them in red. That's how I decided to identify them. And then we can rearrange them so they're together. They're already together, so we don't have to do that. And then add the coefficients. Remember the terminology for coefficient. It's that constant number in front of the variable. So I'm going to simply add 5 and 3 to give me 8. And we can't forget our variable, so 3x's plus 5x's give me 8x's. That makes sense. Just like oranges. 5 oranges plus 3 oranges is 8 oranges. And we're going to do the same thing here. We have all 3 of these are alike, so we can combine the coefficients. 5 minus 2 plus 6. Well, 5 minus 2 is 3, plus 6 more is 9. So that gives me 9y. And that's how you combine like terms. Simple enough. So let's do a couple more so that you can understand what it looks like. What would this be? 4 oranges plus 3 apples equals... And the pause that you get right here is necessary because you're tempted to say 7, but 7 what? Right? And that's the problem. They're not like terms, so that you cannot combine these under one word that fits everything. You're going to say 7 pieces of fruit or something like that, but they're not 7 oranges or 7 apples, so you're going to have to keep unlike terms separate. All you can say about this one is there's 7 oranges. I'm going to oranges plus, what did I say 7 for? 4 oranges plus 3 apples. That's the best way you can combine them because they don't have the same terms, so you can't put these together. So that's how that will look. And again, this is how it be written, and you will see it written mathematically something like 4x plus 3y, right? So you can't add those together because the terms are completely different. We can't add oranges and apples and say we have 7xy. It doesn't work that way. You can only say I have 4x's plus 3y's. So I just want to make sure I drive that point home. Now, let's practice and see if you got it. So first of all, our first step was to identify like terms. Well, I noticed I'm going to start with my variable with the highest exponent. You don't have to, but it's traditionally kind of like algebraic etiquette to do so. So we're going to start with our x's. And I see a x to the 1, x to the first power, if you will, x to the first power. And those are like terms. Now what do? I can rearrange them so that they're next to each other, but I don't think it's necessary. So I'm just going to go ahead and combine the coefficients. 4 and a positive. See, it's going to take this sign here, positive 4. So that's going to be 7x. One of my habits is like to go ahead and cross those out now that I've combined them in this piece right here. I put both of those here at the 7, so I don't need those anymore. And now it's going to be easier for me to see what's remaining. I have two constants, 7 and 5. Can I combine those? Yeah, those are like terms. So 7 and 5 gives me a 12. So that's the best I can do at simplifying that. Move this over a little bit. All right, so I'm going to take my highest exponent. I see an x squared and an x squared, and I don't see any more. So I can combine the like terms. But be careful on this one because we do have a coefficient of 7. And we have, actually, let me erase that. Coefficient of 7. And what do we have right here? Don't say 0. Yes, it is 1. So again, 1s are not written usually, so we need to remember to make sure we either write it or just remember that it's there. So that's 7 plus 1 is going to give me 8x squared. Cross those out. And let's go to the next variable with the next lowest exponent. So we got 8x and 4x. So I like to identify those by underlining or circling so I know where they are. And I'm going to combine by adding the coefficients. So that now gives me 12x, and I'm done. Moving on. All right, pretty simple enough. Did we accomplish our goal? Absolutely. Our question we wanted to answer is, how do I simplify expressions with like terms? And we just found out all you do is add the coefficients in front of them. Thanks for tuning in again. Again, I'm Brandon Clayton, the Algebra Guy, and I will see you next lesson.